All right, let's talk about data management. So there's a lot of different tricks that you'll want to do to process your data to make it more presentable or ready for further analysis later. Some of those things to do are creating new variables out of existing variables, recoding, renaming variables. How do you handle missing values is important. You can also do type conversion, sorting, merging, and subsetting. Okay, so a lot of little things to talk about. So working example, I'm going to jump into a working example because most of these tricks are best just illustrated. This is one that's similar to your book. So 5 managers were asked if they agree on 5 questions. So 1 is strongly disagree, 5 is strongly agree, and everywhere in between. And there are other variables of interest like gender, country, date, and age of a manager. So let's create these variables one at a time. Okay, so there are my variables are now created. I'm going to make a data frame using data.frame. I'll put manager first, then date, country, gender, age, and the answers to these questions. Okay, it's always a good idea to type your data set to make sure that everything looks okay, and it does. All right, so let's talk about how you're going to create a new variable from existing variables in your data set. So first you'll want to apply the transformation, whether this be averaging variables or taking a log or something of that nature. First you'll create the transform variable first, then you'll add it to your existing data. So be careful about using attach and detach too much, because once you've altered the data frame, you can't detach it. So you have to be a little bit careful about getting a little too comfortable with attach and detach. So here's the pseudocode. So remember, we'll create our new variable first. So here you'll apply a function to variable 1 in your data set, variable 2 in your data set, and so on, whether this be average or logarithm, etc. So function could be any function you want. Then you're going to use this pseudocode where you say, I'll take my existing data and I'll use the data frame function, and this will stack the new variable to the right of the existing data frame. And you can rearrange the ordering. We'll see how to do that later. And you'll create this new object called, and you can call it whatever you want, but it'll be called my data for this pseudocode, for example. So let's just look at our leadership data frame. So below, I'm going to create a new variable called qbar1 and 2, which is the average of questions 1 and 2. And it's always a good idea to make sure that you get comfortable with the structure of your data. So that is, if we're going to take the average of variables 1 and 2, we might want to make sure that they are numeric, and indeed they are numeric, and there are their values. All right, so qbar1, 2, what I've done is taken the leadership question 1 variable and the leadership question 2 variable, added them together and divided by 2, so I've taken the average. So again, qbar1, 2 exists, it's the average, so 5 and 4, that average is 4.5, 3 and 5, that average is 4, and so on. And now I'm just going to say, here's my existing data frame as leadership. I'm going to run data frame, and then I'm going to put this new variable to the right of it. And now I have my new leadership data set where this guy is the average of questions 1 and 2. And if I want to remove this variable, I'm going to remove it now. One thing you can do is take data frame, and then minus 11 says remove the 11th column. So this is the 11th column. So I just want to undo what I did there. I just wanted to illustrate. Okay, so that's the basic idea. Let's look at recoding and discretizing variables. So you'll need to use logical operators, and we will learn more about these later, but the main ones are going to be less than or equal to, greater than or equal to, not equal to. So be careful that you don't use 1 equal sign. Remember, that's another way to assign a value to an object, is 1 equal sign. This is X or Y. This is X and Y. So just to illustrate, let's run through some pseudocode briefly. So what I'm going to do is I'm going to look at my data. I'm going to refer to the variable that I want, and I'm going to apply a condition. So this could be, this will go out and get the data for that variable, and the condition might be see if it's less than 25, and you'll assign a new value whenever that condition is satisfied. So condition will return, condition is going to be a true or a false, whether, so you'll create trues or falses using these guys here. And then you could have a new variable and assign it a new value based on that condition. So low, medium, high, etc. And let's just look at an example. So in our leadership data, sometimes if you work with, if you have data coders or data people that their job is to input data, you might not agree with the way that they record values. So one example is this value 99 probably doesn't really mean that that person was 99 years old. It might be if that person's age is not available, input 99. So we really wouldn't want this coded as 99. So I'm going to create a new indicator. So you'll notice what this says is let's go and look at all of the values of age and ask ourselves, is it equal to 99? And the answer is, if you look at the age variable, false, 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 true. And so this will allow us to refer to this element in the data set. So what I'm going to do is whenever I have leadership age indicator, what does that do? So this is my age variable, and it just returns this guy because my indicator is true when this guy is 99. So now I can refer to that guy and write over the top of it. So I'll take this guy here and assign it value NA for not available or not analytical. I can undo that using this code. So again, I'm going to replace this and turn it back to 99 and give you a couple of different ways to do this. So that another thing you can do is this code here. This will say go get the leadership age variable and see and return the values when it is equal to 99. And then when that value is equal to 99, change it to an NA. Okay, so the bracket, remember, refers the bracket refers to the element, tells R which element of that vector to return. So all I really did actually was replace this guy, which is my indicator. I don't have to create that indicator first. I just didn't want to throw too much code at you at once. So all this is really going to do is return trues and falses because that's my indicator up here. And so this will be true when the value is equal to 99. It returns that value, and then I'm going to write over the top of it with it, NA. Okay, so you just have to practice that to get good at it. Let's create a new age category. So let's create this new variable, leadership age cat. And so notice I'm going to create a new variable called age cat. And it's going to have value elder whenever the person is older than 75. Now notice here, this line of code, if a person's greater than or equal to 55 or less than or equal to 75, it'll assign it a value men. Or I could do middle-aged. If a person is less than 55, the age cat variable will be assigned value young. So notice it actually created a new variable on the fly. So this guy didn't actually even exist, but we added it on the fly. So here we have young, 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 young. So everybody was young according to this definition. Everybody was less than 55. You'll notice one person's age was not available or not analytical, and so it said, I can't determine if this person's age is less than 55 or greater than 55. So it returns another NA. And because this is a factor, it has these bracket NAs. Okay, let's talk about renaming variables. So this one, there's lots of ways to do this. The easiest way is to use fix, which remember will bring up your data set and you can add names in the editor, the built-in data editor for R. You can also use row names or call names. We've seen this a little bit already. So let's just briefly go through this. So the pseudocode is, if you want to use names, you say names of my data, and this will get the ith name, and this will rename it to this new variable name. Or you can use, like I said, fix of my data. So let's look at leadership. I can pull up, I can run fix of my leadership data. It will pull up my data set, and I can just manually go in here, type a new value, change it to a numeric, etc. And then once I close it, the results will be saved. Names of leadership. So let's just see exactly what this is going to do. So if I type my leadership data, you'll notice my names are manager, date, country, gender, etc. If I have a big data set, I might want to just see what are the names so that I know how to refer to these guys. And so names of leadership, that will list the names. And I'll notice the second name is date. So I might want to change the second name to test date. And that's how I would do this. So this says go find the second name of the leadership data, change it to test date. Okay. I could also do call names. So how these works, call names and names will return the same thing if you're dealing with a data frame. Other structures, not necessarily the case. All right, let's talk about missing values. So some functions get confused by NA, but some don't. So some, like mean, for example, you can check, but mean might remove any missing values and compute the mean of the observed values. Another thing that you can consider doing is removing data with missing values. Be careful about doing that. There's a lot of research out there that suggests that that's not necessarily a good idea. It's very rarely a good idea, though whether or not that's a good idea, the impact of it depends on how many missing values you have and what kind of analysis you want to do. But that's for another course. So pseudocode, I can use this is.na of my data, so that will return trues and falses whenever any of the values are NA. So for example, well, we'll see an example in a moment. So I can also use n.na to see how many missing values I have or which values are missing, and then I can use new.data and just run this na.omit, and it will automatically return a data set where whenever an element of the data set has a missing value, that entire element is removed. So let's look at the leadership data again. I have these NAs here. And you'll notice is.na returns false all the times where I don't have missing data, but here I have a true for this NA and true, true, true for these NAs. So let's see what the na.omit does. So you'll notice it removed all of the information, which is why you might guess this is not necessarily a good thing to do. So for example, it removed managers 4 and 5 because there was one or more NAs for their variables. So even though I had this information, 3, 3, 4, 2, 2, 1, it removed that entire element. Okay, type conversion. You can convert most types of data, so numeric, character, vector, matrix, data frame, factor, logicals. And how well this works just depends on class of the data that you're working with. So the pseudocode is, you can always check is.type, so is.matrix, is.vector, is.numeric. That will return a true or false. And if you want to coerce a variable into a new type of variable, so for example, you might want to coerce a character to a factor. We've seen this. You would use as.factor or as.matrix if you wanted to coerce a matrix and save it as a new type of variable. So let's look at an example. So here, complete.qs, what is this doing? This is creating a matrix. So cbind is creating a matrix for question 1, question 2, and question 3. So these are my completed answers. So notice I can run this code. Here's my new data. It's just a matrix. Is numeric? The answer is true. Is.matrix? Yes. But I might want to save my complete data as a data frame. So notice it's not a data frame. It's saved as a matrix. So most data analysis functions work better on data frames. So I'm going to save my new complete data as complete.qs.df for data frame. And I'm going to run as.data.frame. And now, if you look at it, it is a data frame. Okay, so for example, notice if you run plot, if you apply plot to a matrix, it just plots the first and second column. But if you look at the data frame and apply plot to it, it creates a plot that you probably more likely want. So of all of these variables. So just to recall, data frame, the structure of an object, very much determines how functions are going to interact with it. And this is an illustration of that. All right, let's look at this guy. Here I have a logical true, true, false. Is.logical, yes. Let me run is.numeric. No, it's not numeric. Even though it's numeric, even though it's not numeric, I can coerce it into being numeric by saying as.numeric, and it will change logicals. It'll assign a value 1 for true and false for 0. So here's x. If I change this to numeric, it'll return a value of 1 for trues and 0 for falses. And recall, sometimes functions are smart enough to coerce objects into the appropriate objects. So for example, I can't theoretically take the mean of true, true, false, but I can change that to numeric, then take the mean. So mean has a built-in coercion. So it will coerce that into numeric, then take the mean. All right, let's talk about sorting. There's a lot of ways to sort, but the simplest way is through the function order. So NAs are always ordered last by default, so that's good to know. But you can read the help file for other ways to treat NAs. So here's the pseudocode. So here I apply this order function. So this is going to order the data in my data frame by variable 1 first, and then by variable 2. And you'll notice, what's this going to do? It's going to return values 1, 2, 3, 4, 5, and so on, which refers to the order of that element of the data set. And then you'll notice you have this comma, so it'll say create new ordered data set, but rearrange the rows to be ordered according to this. So an example will clarify this. So for example, let's look at my leadership data, and suppose I want to order by age You notice if I put a negative in there, that's a clever way to order by age in ascending order. Default is descending. So you'll notice order of my leadership in ascending order. 32, that's the second oldest person. 45, fourth oldest person. 25 is the youngest person, first oldest. 39 is the third oldest. And remember, NAs always get ordered last. So I can also order by gender. And all it knows is that 2, so male gets 2, 3, 5, female, and male gets 1 again. So this is male and this is male, and the numbering for males is arbitrary, so it breaks ties. You can read the help file to see how it randomly breaks those ties. But in any route, it assigns M's as 1 and 2 and F's as 3, 5, and 4. So let's look at how I would order according to gender and then in ascending order for age. So you'll notice here I've put 2 and 5. That's for my gender. And then I've ordered leadership by age. Okay, so let's just run this and see what it does. It's a little easier to see. So the important thing that I want to point out is that this is just returning and ordering. Then you use this to determine the order of the elements and what order you want to list them. So you'll notice if I order by gender, then by age, what did it do? Females first, then by age, 45, 25, 39, 32 for my males. And it ordered by gender first. And notice it put the NA last within gender. And then it ordered by age second. Okay, so you'll just want to try different things around there. All right, let's look at merging. So the most common methods for merging are cbind, rbind, and then also merge. Merge is useful when you have applied a lot of ordering to keep track of the order in which the variables should be entered. So pseudocode is rbind, cbind, my data set 1, my data set 2, and merge is a little bit more sophisticated. It will merge these two data sets, and then you can merge it by variable name. So they have to have the same variable name, and it'll know to match the appropriate values with the order. So let's see an example of that. So here's my leadership data, and suppose I have more data. I'm going to create this as data frame, and I'm going to create another variable called manager and question 6. So the manager is going to be useful later, so I know to assign the question 6 values to the appropriate manager. All right, so more data, simple data set, looks like this. I have manager and then question 6. Now suppose that I sorted my original data, and now I have my more data looks like this, but my sorted data looks like this. So I have to be careful. I want to assign question 6. This number 1 should be associated with manager 1, but if I just tack the question 6 on the edge, it's going to give that value of 1 to manager 2 when in fact it corresponds to manager 1. And so let me show you this. For example, this would be an incorrect merge of data sets. So question 6, a value of 1 was assigned to manager 2, but actually that should have been assigned to manager 1. Because we've sorted the data, R didn't know that the data was sorted, so the actual value of 1 should be down here for manager 1. So how can we do that? The merge function is an easy fix. So if I run merge, here's my two data sets. I have to tell it this is the variable that where they have the same value. So this identifies the elements of your data set, or the rows. So if I run this guy, you'll notice here it did a couple of things. It associated question 6 value 1 with manager 1, question 6 value 5, that is with manager 5. Manager 2 had a value of 3. Okay, so we've appropriately merged our data sets using manager as an ID to know which values go with which person. And if you wanted to clean up, I could reorder. If I wanted to put my 6 questions here, for whatever reason, this will say, go get the leadership data and use the first 10 columns, then get the 12th column and get the 11th column and stack them in that order. So I've moved question 6 over to here. All right, subsetting and sampling. So you can refer to elements or portions of a data frame using this syntax, bracket XY, and there's lots of other different syntax you can use. You can also take a subset or sample from your data set using the sample function. So if you have a huge data set, you might just want to learn about a few people in your data set to make things more manageable. All right. My data frame minus A will remove those rows. My data frame AB will get those rows and columns. My data frame A will get those rows. My data frame B will get a set of those columns. Okay. Sample is how you'll sample from your data frame. Let's look at an example. So here's my leadership data. What's this going to do? 1 through 10. It just goes and gets columns 1 through 10. And here's the code I just ran before. What does this do? It just reorders my columns. It says put the original columns 1 through 10 first, then do the 12th column, and then do the 11th column. So now it looks like this. What's this going to do? This is going to remove the first, third, and fifth row, or equivalently, how would I refer to those rows? I could also do concatenate and 4. Truth. It says go get the second and fourth rows. I can take, to show you how this sample function works, I list the elements first and again read the help file, but I want to take a sample of the numbers 1 through 5. I'm going to take a sample size of 3 and I'm going to sample without replacement. So replace equals false. So how would I run this? You'll notice here I have this sample. So what's this doing? In row of leadership, what's that returning? It's getting the number of rows for the leadership data, which is 5. So just a little bit more generic code that could be used for whatever your data set is. Take a sample of size 2 without replacement. So I'm going to basically put that function, well, I am going to put that function. You'll notice here, this is going to get those rows. Which rows I get are going to be determined using the sample function. So you'll notice if I run this function over and over again, it's getting a random sample. So it's not going to return the same 2 people every time. Here I can get a sample, size 3. and randomly determine which rows to get. All right,